Hello everyone, and welcome back to a new episode of SHENZHEN I. Let's get started on a remote kill switch. What is this? I would like to have a remote kill switch for autonomous systems robots. This is in case of failure of the autonomous system, of course. Of the autonomous system. Of course, such a switch would not be needed if we always designed the system correctly. We should make this. I will send the transmitter and we will grade the receiver. Okay? Great, there it is. Radio RX is a non-blocking X-bus input connected to a radio receiver. Power 0, 1, and 2 are simple outputs connected to high-power switches that control industrial equipment. When a data packet is received, read it and do the following thing. If it's -1, do nothing? Wait, what? Oh, I see. Okay. So when we get a -1, so the idea is we're receiving packets, and packets are 1 or 2 parts. A 1-part packet is this -1 saying do nothing. But it turns out we don't actually do nothing because we're also keeping track of how long it's been since the last packet, including do nothing packets. So whenever we receive a packet, we'll need to reset our reset our internal timer back to 5. Otherwise, if we get a packet that is a 0 or a 1, we need to read another packet and use that second one to decide which input to toggle, either on or off. So obviously a mux looks pretty cool, right? I think we're probably going to want 2 chips. One that's mostly in charge of the radio and one that's mostly in charge of this thing. The idea that I have in mind is that we're going to use this to store basically a 3-digit number, right? And we're going to have the chip that controls this guy is going to sort of have a 2-way communication channel with this, where he reads the current state as X-bus, the current state of these 3 pins, and then further reads a digit number from this guy. Oh, and then also reads whether to turn it on or off? I guess. And then he sends that back. He sends the new number back to this. Right? Would it be useful to use our accumulator instead of this thing's whatever? Maybe, because, yeah, whatever is on this is going to be exactly what he sent there last, so we won't actually have to read it back. But I guess it's free to read it back, so why not? Oh, because... no, I don't know. Oh, because if it's already in ACK, then we don't have to spend an instruction reading it, because the digit setting instructions sort of implicitly operate on accumulator. So we save an instruction that way. So I kind of envision, in the ideal case, this guy's loop looking something like this. Sleep X for X1, which is the one wired up to something down here. And then, how does the S digit work? SDGT? No, let's just search for DDT. How do all these digit things work? DST. Sets the digit number identified by the first operand to the value of the second. Okay. Fine. Oh, interesting. I forgot. These are already like 0 indexed, which I think are the way we want it. So let's look at some of our inputs. Yeah, we're receiving numbers 0, 1, or 2, and so we can just set 0, 1, or 2 on this ACK. Okay. Honestly, we might not even need this guy. We could probably make do with a single one of these, which would be cheaper than 2 of these. Right? If we stored the current... Ah, right, I forgot. We have more tracking to do of like when to kill this thing. So we have to store the accumulator, or we have to store a timer in this guy's accumulator, probably, right? Now what happens if we go 5 time units without getting anything powered? Do we then ever later get more power? Yes, we do. So the robot might be killed for a while. And if so, that doesn't mean it's killed forever. That's a little bit trickier. Because the obvious way to implement killing off the robot would be to just have this guy, the main controller, bypass this little subcontroller, and instead write directly to this thing all zeros. The problem with that plan is that then when we I think that plan's okay, actually. It just means that this guy will have to actually read from this into ACK. Rather than just implicitly storing stuff in ACK. Because the problem is this ACK will be stale if we ever do that override, and we'll need to reread the value from here. But so we can just reread it every time, and we'll waste one instruction that way, but it won't be too big a deal. Okay, so what about this? Do we need a large one or a small one down here? The idea is just going to be to test how long it's been since we, well, right, we need a large one because ACK needs to store how long it's been since we saw an input, and we need a place to store the input to look at it to decide if it was, if there was any input or not, right? Like we always do with these X bus inputs. Okay, so let's move this a little closer to the point of interest. Yeah, there we go. And, let's just finish writing his program, shall we? Sleep for X1, move X 3 into ACK, and SD, no. DST, digit set, x1, x1. So we're going to read from the x bus input twice, which is fine, which is great. And then move ACK back to x3, and I think that's it. Cannot read pin twice? Oh, no! Alright, well that's fine. We have plenty of spare x bus inputs. X0. So these guys will have to have a redundant communication channel, which is like kind of dumb, but okay. So it's going to look kind of like that. So let's wire those up like so. And this guy needs additionally an input to here. Let's move the and we'll just apply the receive there. Okay, so interesting fact is that this guy is like not doing anything. He's hardly doing anything at all, really. But I think what he's doing is valuable enough that we want to keep him, because we're actually using his accumulator for something as a place to do math. And we need a place to do math over in this chip too, so I think that's fine. So what we're going to do now is start by moving x1 into not ACK, but DAT. Test if it's equal to minus 999. Is that equal to minus 999? If it is, sub 1 from our ACK. Test whether ACK is 0. If so, move a 0 to x3, disabling the robot completely. Now what? Well, actually, we can just, alright, what order does setDigit take its instructions in? The digit number specified by the first operand to the value of the second operand. That's a little awkward, isn't it? Because we kind of wish it were the opposite, don't we? Wait. The digit specified by the first operand. Yeah. Ah. We can leave it in DAT for now and move the next XBus input, which is on X1, over to, gosh, which channel does this guy want that on? He wants it on his X1, which is our X2. And then we'll move that to oh shoot, we need to test whether it's -1 actually. Alright, so we need, let's finish up this branch of the code and then we'll figure out what to do with the rest. Move dat over to the X0 output. So that's giving him the instructions to do, to actuate the robot somehow. But now we need to figure out how to deal with the timer, because I've sort of only kind of half-heartedly dealt with it. Oh, so we don't even need to test whether it's 0 exactly. We need to test whether it's -1. Alright, hang on. Oops, -1. So first we see, was it -999? Oh, no, this is right. We were testing a different thing. Okay. Ah! Test whether it's 0. Okay. Otherwise, so if the ACK is 0, that means we're out of time. Wait, no. If that is minus 99, now we test. We move a 0 to x3, and otherwise we're going to do all this other stuff. We got an input that wasn't. You know what? Let's not try to be fancy here. Let's just jump to top here. Top. Now what we want to do is test equal dat of -1. And if it wasn't -1, we're going to do all this other stuff. And also, we're going to move 5 into ACK. Seems like we could maybe do some kind of sort of test compare with -1. If it's less than -1, then we want to jump to the top. If it's greater than -1, then we want to write to this secondary controller. And if it's equal to -1, we kind of want to do nothing, right? So this is actually looking pretty good. Instead of test eq, well, hang on. Yeah, I can't figure that out. It's complicated. Okay, so if it wasn't -1, do these things. Instead of jump top, let's jump end. And in end, we have to sleep. And sleep 1. So this is my sketch. I imagine we're missing an important step here. And also, I'm pretty sure we could shrink this down to just one, to a smaller size. No, because we need both registers. We could probably use fewer instructions. All right, well, we're probably super duper wrong, but I want to see how it runs. So step is a -999, yes. Therefore, we sub 1. Is the accumulator 0? No. Whoa. Okay, well, there's a problem. We forgot to jump to the end here. I guess we need to do that here? Wait. Oh, huh. Okay, so let's actually label let's label this with go. This is where we're going to actually do stuff. And if that wasn't -99, we'll just jump to go. Okay? Otherwise, we have this sub and we have a test equal. And if the accumulator hits 0, then we kill the robot and jump to the end. Getting messier still, but we had a lot of instructions to play with, and this seemed like a pretty easy way to think about the problem. How did we end up in go? Hello? Oh, this should no longer be a plus because we're doing it. This is the case where we decided ACK was -9 and 9. Okay, again. So we subtracted 1, we decided we didn't need to kill the robot, then we jumped to the end, which is a sleep 1. Okay, that's gonna happen for a while. Oh, hang on, I skipped over the -1, not noticing that it's at all interesting. Okay, is it -9 and 9? No. Therefore we jump to go, actually do a thing, put 5 in our accumulator, saying the robot now has a grace period of 5 time units. Test equal dat of -1, yes, therefore just sleep. Alright. Now we're counting down, but, oh, told the robot not to do anything. Okay, yes, read all these things. Now finally we get an actual 1. Is it -9 and 9? No. Therefore, jump to go. We move 5 to our timer. We test whether it's -1. It's not. Now we write x1, that's this 1 here, to our x2, which we never wired up. Oh no, we did. It goes up here. Great. Now this guy actually receives it and puts it in his accumulator. No. He wakes up and reads from this, puts that in his accumulator. Then he reads this thing. Oh, he reads them in the wrong order? Does he read... What? He wants this one first. I mean, I can send them to you in whatever order you want. That's no problem. I just hope he doesn't want them both active at the same time, which would be kind of a pain. We'd need another chip just to send them to this stupid guy. So let's put our breakpoint here. Okay. We got a 1, so we actually do move dat over x0. Oh, and now this guy needs to be sleeping for x0. There you go, you can have a thing. He reads this. No, he wants them both at the same time. What a sleazeball. I mean, we can do that. It's fine. We just need to use a different chip. We need to write one of them to sort of an out-of-band thing, a simple I/O pin that the two of these share. Yeah. Which is not too hard to arrange with let's see. Oops. Rip. Oops. Don't throw that away. He has important code on him. But take this, put it here. Pin type mismatch. I know. We'll get there. This is our. This was our x3. So instead of x3, it needs to be x1. This guy was wired up like this, but now needs to wire up like that. And he needs to write, instead of x2, he writes p1, does those in the opposite order. Copy all this, put it here. So his x0, that I guess x0 is still the right thing to sleep on. Yes, correct. And then move x1 into ACK. That all looks good. And then move ACK onto x1. How's that look? Interestingly, no, nothing is interesting. I was thinking that that means we could now use a smaller chip here, but the registers were always the concern. The concern was never the I/O chip. pins. So I just keep forgetting why we have this large chip. Aside from the fact that we're using like a ton of code, which, you know, that's relevant too. Okay, here we go. So let's try it again. We discovered we have a relevant input. We move x1, that's this thing, onto our p1. Now there's a 1 waiting here to be read whenever he wants it. And we move that to x0. Now this guy wakes up and he moves the zeros here onto his ACK. And he does a digit set of what this x1, which is a 1, with this x0? No, one of them should be p0. Bleh. I'm not sure if we got these in the right order. Yeah, advance. Step, 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 step. Now he sets... Okay, we got the ACK to be 1. 1? Shouldn't it be bigger than that? We're setting field 1, right? So that should be the tens digit. I'm not convinced. Digit set, and they were both 1, right? Also, why is a 1 still sitting here? Did we move to x0 too many times? I guess we did. We moved to x0. Oh! Digit set x0. p0. He was reading from this instead of this. Step, step, step. Now we read the old state of the robot. We do a digit set based on what we read here, and we get 10. And we write out to the robot, here you go, turn on 10. Incredible. And now we read a 1, and it says to activate input or output number 2. So we read all those and we say, here's your 2, here comes your 1. He reads the old state, finds that it was 10. He sets digit 2 of that number to be 1, yielding hopefully 110? Wait. Why did moving x1 to ACK yield 0? I'm confused. He read a 20. Why? Do I not understand how this thing works? It's supposed to tell you... Wait, a 20? Do I have this upside down? I might have it upside down. Alright, try again. Digit set x0. Oh! No, wait. Digit set sets the digit of ACK specified by this digit. Oh, it should be probably P0 and X0, right? P0, X0. But I still don't know what happened with this. So reading this should, as I understand it, yield 10, right? Step. Move X1 into ACK. He gets a 0. What? dx, whatever. The X buses are all read-write. What? Oh no, at any given time it's either in input mode or output mode. Wait, maybe this is fine. Writing an XBus value will put its simple I/O pins into output mode. with the specified output values. Reading a value from the DX will put its pins into input mode, clearing any previously set output values? What does this mean? Does it mean that we can't read a value that we wrote? Clearing? But it didn't clear. This is still set. What? What does this mean? I thought we were able to read from this thing as well as write to it, but it seems that we can't. Okay. So in the worst case, we can fix this by upgrading this guy to a larger chip. And using his register to store the state. We would need to we'd need to also upgrade the communication protocol between these guys somehow. So you can't... Clearing any previously set values. What does this mean? Alright, let's continue just seeing how this thing behaves. So it's all zeros. Is it in like input mode or output mode? Can I tell by mousing over it? No, not obviously. Alright, so here we're about to write a thing to it. Who knows what we write? We give it 100 and it says, yeah, I'm writing 100. Great. And now, I guess, we get to see how the breaking stuff works. We determine, oh yes, accumulator is 0. Move 0 to x3. That works. We turned it off. Great. So here we read these ones and we say, okay, go ahead. Figure out what to do. It reads a value and the value it gets is 0. So I don't know how we can tell if this is in input mode or output mode. Or like what the hell the deal is there. Because there's still a 1 right here. Man, I don't know. So, can we just enrich this guy's life a little bit by using, like, right now he is using his accumulator. We don't necessarily need him to have another register. We just need this guy to no longer bypass him, but instead send a special message signifying, please reset everything to 0. And then have this guy understand that message. And I think the way to send that message is to first put that special value onto this simple I/O pin we're using for out-of-band communication. And then send any message over the X bus to wake it up. And then this guy is going to sleep on the X bus, but not actually immediately read the X bus. Instead, he's going to check, oh, is this thing set saying to throw away all my state and go back to 0? If so, we can actually send the 0 over X bus, and we'll just say, move our X bus from here to here, resetting this thing, and also reset dad. Otherwise, actually read these two values and do all the stuff we were doing here. Okay, so I guess that's what we're gonna have to do. Makes me kind of a little sad, and I don't quite understand how this input and output mode thing for this works yet. But I think we can fit it all into the hardware we currently have. No, right, we need, wait. Right, I keep thinking we need a DAT register, which we don't. We're going to just, we're improving the communications a little bit so that this guy's ACK becomes the authoritative value rather than this being the authoritative value, since we can't read from this. So when we decide to murder the robot, instead of sending a 0 to X3, which does not accomplish what we desire, we do two things. We first move 100 to P1 and then move 0 to X0. That 100 is going to be the special value that this guy interprets to mean reset everything. Okay, so what he's going to do next, he's slept for X0, and instead of doing this move X1 to ACK, he's going to test equal P0 for 100. If it is, then move X0 into ACK. Otherwise, do this digit set on ACK. Right? So in both cases, we've read X0 exactly once, which is what we want. And we've adjusted ACK either by making it 0, reading the 0 that was on the X bus and putting it there, or by modifying it according to this digit setting nonsense. And then in either case, we move our ACK to X1 and we wait for new input. That seems like a pretty small change, not too bad. Let's make sure that works. Yep, looks good. Yep, we added, and now we're successfully setting 2 inputs? I don't see 2. Oh, one of them got turned back off, but they were both on for a little while. Okay. And now we're gonna, yeah, we get some -1s here. Yeah, great, great. We get another -1 just in time before we murder the robot, I think. We get a 1, 0 saying turn on power 0, so that should be all 3 of them on. Look, not all 3, these 2. And we go for a while, and we get this -1 to keep the robot alive, but then, oh no, it's been 5 time units, and this is the exciting part for us. Is it equal to -999? Yes, therefore subtract 1. Oh, the accumulator is 0. So we put 100 on our little out-of-band network thing here, and then send a 0 over X bus. This guy, who was waiting, says, oh, I can wake up. Test equal whether it's 100. By golly, it is. So we move the value on X0, which is the 0, into ACK. And we move ACK to X1, shutting everything down. Great. So there goes our robot, perfectly safe and within normal operating parameters or whatever. And as long as we keep getting input, he works fine. And when we stop, we shut him off. Great. How'd we do? on the low side of normal for cost and power, so that's pretty good. Someone did it with so little hardware. I think there's even a blip up here where someone did it with like just one of these guys and one of these, which seems extremely hard to me because you need so many registers, right? Maybe he did it with two of these and one of these, but that's more expensive. Two of these, I should say, and one of these. That seems very hard to do. Of course, you need more registers. Like, I don't know, man. I'm pretty happy with how we did it. Let's go see what the boss has to say about our robot murdering machine. Can't be too careful when you make robots, am I right? Or am I right? I'm learning some more casual style English from Joe. You scared me for a second there. J. Huh. I guess J might be his initial or something. Sheng-Ji? Okay, cool. Well, we have a bunch more like things to do, but those are all going to be in a future episode. Thanks for watching, and I'll see you next time.